If you've ever stood in your backyard, looked at your garden, and thought, I wish I could get free electricity from this same piece of land without killing my vegetables, then you're not alone. That exact thought is what pushed me to build something I never expected to work this well. For a long time, I wanted two things at once. I wanted to lower my electricity bill, and I also wanted to grow more of my own food. But every time I looked into putting solar panels on my property, it felt like I had to choose. Either I cover my garden with panels and lose the growing space, or I keep the garden and keep paying high electric bills. It didn't seem fair. Then I started learning about something called agrivoltaics, basically putting solar panels high enough so you can still grow vegetables, or even graze animals, underneath them. The problem? Most of the systems I saw were either huge commercial projects or they cost way too much money for a regular homestead. I'm talking $5,000 to $10,000 just for the mounting structure. That was never going to happen on my budget. So I decided to try something different. I wanted to build a simple, elevated solar structure. Myself, something strong enough to hold real solar panels, but cheap enough that I could actually afford it. And I wanted to do it in a way that still let me keep a productive vegetable garden underneath. But here's the part that surprised me the most. I ended up building the whole thing for under $1,500. And after a few months of running it, my vegetables are still growing strong, and I'm actually producing real power from the same land. Now, I'm not an electrician or a professional builder. I'm just a regular person who likes figuring things out and hates wasting money. If I can build this, you can too, especially if you've been looking for a practical way to get both electricity and food from your land without spending a fortune. Before we get into how I actually built the frame, let me show you exactly what materials I used and why I chose them. Because this is where most people either overspend or make things way more complicated than they need to be. Here's what I ended up buying. First, I needed something strong for the main posts. I went with 4X, 4 pressure-treated posts. They're sturdy, they hold up to weather, and they're not crazy expensive. I used 6 of them for the basic structure. For the horizontal beams that would hold the panels up high, I used 2x6 lumber. It's strong enough to span the distance without sagging, and it's easy to work with using basic tools. To connect everything and make it adjustable, I used galvanized steel brackets and plenty of lag bolts. This part is important because you want the structure to be solid, especially if you live in an area with wind or snow. For the actual panel mounting rails, I bought a basic solar mounting kit made for ground mounts. I didn't need anything fancy, just something that could hold the panels securely at the right angle. And finally, I needed solar panels themselves. I went with used or refurbished panels I found locally. They were a lot cheaper than new ones, and they still produce plenty of power for what I need. Altogether, the materials came in right around $1,350 before tax. That's including everything: posts, lumber, hardware, mounting rails, and the panels. Way cheaper than anything I saw online for pre-made elevated systems. The key was keeping everything simple. I didn't over-engineer it. I didn't buy fancy adjustable trackers or expensive aluminum extrusions. I just needed something that would lift the panels high enough for me to walk and work underneath while still letting enough sunlight reach the plants. Now this is where it gets interesting. Because once I had all the materials on site, I realized the real challenge wasn't buying the stuff. It was figuring out how to put it together in a way that wouldn't fall apart in a storm and wouldn't shade out my entire garden. That's exactly what we're going to cover next. Once the materials arrived, I had to turn a pile of lumber and steel into something that could safely hold solar panels 7 feet in the air while still letting enough sunlight reach the garden underneath. This part required some planning and basic technical decisions. The first decision was height and orientation. I wanted at least 7 feet, about 2.1 meters of clearance underneath, so I could walk, work, and eventually plant tall crops like tomatoes or pole beans without feeling cramped. I also decided to orient the rows north-south. This helps sunlight reach the plants more evenly throughout the day, as the sun moves from east to west. For most vegetables, this orientation works better than east-west in agrivoltaic setups. Next came the foundation. I used 6 4X, 4 pressure-treated posts. Each post sits in a hole 24 inches deep and 12 inches wide. At the bottom of each hole, I poured about 4 inches of gravel for drainage, then set the post and filled the rest with concrete. I made sure every post was perfectly plumb using a level on two sides. This step is critical if your posts lean even a little. The whole structure will be out of square later. After the concrete cured for 48 hours, I started building the upper frame. For the main horizontal beams, I used 2x6 lumber. These beams span between the posts and carry most of the weight. I attach them to the posts using heavy-duty galvanized post caps and 1/2-inch lag bolts. I also added 2x6 cross bracing on the back and both sides at roughly 4-5-degree angles. Bracing at this angle gives the best resistance against wind and racking forces. Without proper bracing, the structure can twist in strong wind, something I learned the hard way on my first attempt. Here's a technical detail most people miss. When attaching the beams, I left a slight 1-2-degree slope across the entire frame, running from back to front. This helps rainwater and snow slide off instead of pooling. It's a small adjustment but makes a big difference in longevity, especially in areas with heavy rain or snow. Once the main beams were up and braced, I installed the purlins, the 2x4 pieces that run perpendicular across the beams. I spaced the purlins 24 inches on center. This spacing is strong enough to support the solar panels and the occasional person walking on the structure for maintenance. I checked every purlin with a level and a long straight board to make sure the surface was flat before moving forward. For the actual panel mounting, I used a basic adjustable ground mount racking system. I attached the rails to the purlins using the hardware that came with the kit, plus some extra self-tapping screws for extra security. I made sure the rails were spaced exactly according to the mounting holes on my solar panels, usually 40 to 48 inches apart, depending on the panel model. Getting this measurement right is important. If the rails are too far apart or too close, you'll have a hard time bolting the panels down properly. I also added a simple grounding system at this stage. I ran a continuous copper grounding wire along the entire metal structure and connected it to a grounding rod driven into the ground. This is required in most places in the US for safety and code compliance. One more technical tip that saved me money. Instead of buying brand new rails, I found a guy locally who was upgrading his ground mount system and selling his old rails. I bought 4 pieces for $180. They were still in excellent condition. Always check local solar groups, Craigslist, or Facebook Marketplace. Before buying new racking, you can often save 60% this way. After everything was assembled, I went around the entire structure with a torque wrench and checked every bolt. Solar mounting hardware should generally be tightened to around 15-20 feet-pounds, but always check the specifications that come with your racking. Loose bolts are one of the most common reasons structures fail over time. When I finally stepped back and looked at the finished frame, it felt solid. I could shake it and nothing moved. The total cost for the structure, posts, lumber, concrete, hardware, used rails, and grounding came in at $870. That left me with plenty of budget for the panels themselves. At this point, the frame was ready. The next step was actually mounting the solar panels, running the wiring, and planting vegetables underneath. That's exactly what we're covering in the next chapter, including the spacing mistakes I made with the plants and how I fixed them. With the frame finally solid and level, it was time to actually put the solar panels up and start thinking about what to plant underneath. This part felt exciting, but it also came with some important technical details I had to get right. Mounting the panels was more straightforward than I expected, but there were still a few things I had to pay close attention to. First, I made sure the mounting rails were perfectly aligned with the holes on the back of each panel. Most residential panels have mounting holes spaced either 40 or 48 inches apart, depending on the model. I double-checked this measurement before lifting each panel up. I used 2 people to lift and position each panel, one on a ladder and one on the ground handing it up. Solar panels are surprisingly heavy and awkward to handle alone, especially when you're working at height. Once the panel was sitting on the rails, I used the mid-clamps and end clamps that came with the racking kit to secure it. I tightened the clamps gradually, working from one side to the other so the panel wouldn't twist or stress the glass. Here's a technical detail worth knowing. When tightening the clamps, I aimed for about 15-18 feet-pounds of torque. Too loose, and the panels can shift in high wind. Too tight, and you risk cracking the glass or frame. If you don't have a torque wrench, Tighten them firmly, but don't go crazy. You should be able to still move the panel slightly by hand before it locks into place. After all 4 panels were mounted, I started the wiring. I connected the panels in series first. This means the positive wire from one panel goes to the negative of the next. Series wiring increases the voltage while keeping the current the same. For my small system, this was the simplest and most efficient way to wire them. I ran the output wires down one of the posts using UV-resistant conduit. At the bottom, I connected everything to a small charge controller and then to a battery bank I already had for my off-grid shed. If you're tying into your house, you would go through an inverter instead. Either way, make sure you use properly sized wire and add fuses or breakers for safety. I also installed a basic monitoring device so I could see how much power the system was producing in real time. It wasn't expensive, but it's been really useful for understanding how much electricity I'm actually getting from the panels. Now came the part I was most curious and nervous about: planting vegetables underneath the panels. I had read that some plants actually do better with partial shade, especially in hot summer months. Leafy greens like spinach, kale, and lettuce tend to bolt less when they get some afternoon shade. Root vegetables like carrots and beets can also handle it well. However, fruiting plants like tomatoes and peppers need more direct sun, so I planted those toward the edges where they would get more light. This is where I made a mistake that cost me some production. In my first planting, I put everything too close together under the middle of the panels. The plants in the very center didn't get enough light and grew much slower than the ones on the outer rows. After a few weeks, I thinned out some plants and left more space between rows. I also avoided planting tall crops directly in the center where the shade is heaviest. For spacing, I ended up using roughly 18-24 inches between plants in the rows, and I left wider walkways than usual so I could move around easily under the structure. Because the ground stays a bit cooler and more humid under the panels, I also had to be careful not to overwater. The microclimate is different from an open garden. After about 3 weeks, I started seeing clear differences. The lettuce and spinach under the panels were actually looking healthier and lasted longer into the summer compared to the same varieties I planted in full sun. The tomatoes on the edges were doing fine, but the few I tried planting directly underneath were slower to produce fruit. At this point, the system was fully operational. The panels were mounted securely, the wiring was done safely, and I had vegetables growing underneath. The total cost for the panels, wiring, charge controller, and basic monitoring came in around $580, bringing my grand total right around $1,450. In the next chapter, I'll show you the actual results, how much power I've been getting, how the garden has performed over several months, and what I would do differently if I built this again. After running this system for a few months, I finally had some real data to look at. And to be honest, the results were better than I expected in some ways, and a little different from what I imagined in others. First, let's talk about the electricity. My small 4-panel system has been producing an average of about 14 to 18 kilowatt hours per week during the summer months. That might not sound like a huge number, but for my needs, it's been meaningful. It's been enough to run my off-grid shed, charge tools, power some lights, and even contribute a bit to the house during the day. On the best sunny days, I've seen peaks close to 3.2 kilowatts coming from the panels. In terms of savings, I estimate I'm offsetting roughly $25 to $35 per month on my electricity bill during the warmer months. It's not life-changing money, but over a year it adds up. And more importantly, I now have a backup power source if the grid goes down for a few days. What surprised me most was how stable the production has been. Because the panels are elevated and get good airflow underneath, they actually stay cooler than my friend's ground-mounted panels. Cooler panels mean slightly better efficiency, especially on hot summer days. I didn't expect that benefit when I first built the structure. Now, for the garden side, the results have been mixed, but mostly positive. Leafy greens like lettuce, spinach, and kale have done really well under the panels. They grow slower than in full sun, but they stay tender longer and don't bolt as quickly in the heat. I've been able to harvest continuously from the same plants for weeks longer than usual. Root vegetables like carrots and beets also performed decently, though they took a bit longer to mature. Tomatoes and peppers on the outer edges did fine, but the few tomato plants I tried growing right in the middle never really took off. They grew tall, but produced very little fruit. Lesson learned. Fruiting crops need more direct sunlight. One unexpected benefit has been water retention. The ground under the panels stays noticeably more moist, so I've been able to water less often. In the middle of summer, that's been a nice advantage. If I were to build this system again, there are a few things I would do differently. First, I would make the structure a little wider and add one more row of panels. 4 panels is nice, but 6 would give me noticeably more power without adding that much more cost to the frame. Second, I would plan the plant layout better from the beginning. I would put leafy greens and herbs in the shadier center areas and save the sunniest outer zones for tomatoes, peppers, and cucumbers. I would also add a simple drip irrigation system from the start. Hand watering under the structure gets annoying after a while, especially when it's hot. And lastly, I would spend a bit more time on the foundation. Even though my posts are solid, I would probably go a little deeper with the concrete in areas with high wind. Looking back, I'm really glad I built this. It wasn't perfect, and I made mistakes along the way, but I now have a working system that gives me both electricity and fresh vegetables from the same piece of land. The total cost stayed under $1,500, and I learned a ton in the process. If you're thinking about doing something similar on your own property, here's my honest advice. Start small. Don't try to build a massive system on your first try. Build something simple, get it working, and then expand later if you want. Focus on making the structure solid and safe first. Everything else can be improved over time. You don't need to be an expert. You just need to be willing to learn as you go and not be afraid to adjust things when they don't work out perfectly the first time. Thanks for following along with this project. I hope this gave you some practical ideas for your own land. If you build something like this, I'd love to hear how it goes.